So if somebody is going to build a real estate recording app on top of it, they want one that's not going to fork. They really want to have a guarantee it's not going to fork. And so we're doing everything we can to make it reliable and stable for people who want to build on it.
Welcome to Hedera Hashgraph's Gossip About Gossip. I'm Daniel Francis.
I'm Ken Anderson.
And I'm Paul Madsen.
If you are a developer, an entrepreneur, crypto enthusiast, or just trying to learn more about how distributed ledger technology and Hedera Hashgraph will impact your industry, then you'll love the episodes that we have coming up. Bookmark us, add us to your podcast app, and stay tuned.
Hi there, and welcome to Hedera Hashgraph, Gossip About Gossip. I'm Paul Madsen. Today's a special episode. I think I say that every time. Today, perhaps extra special because I'm talking to my bosses, Mance Harmon and Leemon Baird. Leemon, a technical question first. So Hashgraph is a DAG, a directed acyclic graph. What does that mean? What are the advantages of a DAG, and how are we similar to other DAGs?
Oh, yeah. It's interesting. We're not using a DAG like other people's DAGs. What we're actually doing is that we have the computers all talking to each other with gossip, which is the fastest way to get things out. And then we record a record of how they talk to each other. And that's what our DAG is. So our DAG is not like a Tangle and IOTA or those other DAGs that are representing something else. All ours represents is a history of how we talk to each other. And then we use a completely different algorithm that calculates a consensus from that. And so we can come to an agreement from that. And so our DAG is only in memory for a few seconds or maybe a minute, and then we can get rid of it. We only need it just temporarily, just to let us know what the consensus is. And so it's very, very scalable, but it's a very different kind of DAG than other DAGs.
So I sometimes see DAGs described as somehow enabling scalability, because in a sense, all participants need not work together or actually come to consensus on the proposition. But if that's the case, how do we maintain security?
You're right. That kind of DAG has terrible security problems, really bad. But we're not that kind of DAG. A whole network is involved. So the DAG is just the way that we remember how the whole network was talking to each other. But we have a requirement that more than 2/3 of the stake is agreeing with the agreement. So it's the whole network involved. The DAG is just talking about how the whole network was talking to each other. And so it doesn't let you just be in a little piece of the network. That would be a terrible security problem. And you're right. These other systems that use DAGs do that. We're really not doing that. We're really where the whole network is talking to each other.
But if every node is talking to every other node, the whole network is working together, how can Hashgraph scale?
So what you do is you use shards where you break the network up into chunks, but each chunk is big enough to be secure, and each chunk has its own DAG. We're not using the DAG to let us do things locally. We're using sharding for that. And even within a shard, everybody's talking to each other within the shard.
So we will shard to scale?
Yes, you can say that. But it turns out that our DAG is very fast. We should absolutely be doing 100,000 micropayments per second, even within one shard. With everyone talking to each other, it looks like we'll easily be able to do 100,000 payments per second, even within one shard. So we actually do very good scaling, even within one shard. But yes, if you want to go to millions or billions a second, then you go to multiple shards.
So Hashgraph is gossip-based. How does that work? If Alice and Bob are gossiping and Alice tells Bob everything she knows, how big a message is that?
So Alice only tells Bob the things that she knows that he doesn't. And since we're all talking to each other and messages spread throughout the whole network extremely fast, there won't be very much that one of them knows that the other one doesn't. So what we find when we're running this is that a sync between Alice and Bob takes a fraction of a second. It usually doesn't take very long at all. And messages spread through the whole network very fast, so that we have consensus and finality within a few seconds. Finality means you absolutely know the consensus. You don't say, I'm just a little bit more sure. It's not like you have 6 confirmations and you keep getting more sure. Finality is you're absolutely positive, and we get that within a few seconds.
What are the bandwidth requirements? How big might a transaction be? For instance, a simple micropayment.
So if you're talking about transactions, Micropayment might be 140 bytes, might be a typical micropayment where I'm paying you something. Now, if I want to store a big file on the system, I could put kilobytes in my message, in my transaction. But usually you have very small transactions.
We tout our performance. What sort of throughput should people expect to see when Hedera goes OA?
Oh, so right now on the test networks, we're throttling it down to be slow. We're not really tuning for speed right now on the test networks. But I expect that when we're running at scale, probably at OA this summer, we'll be able to do 10,000 payments a second and then tune it throughout the year to get to maybe 100,000 transactions per second for payments. Now, smart contracts and files will be much slower, but payments are what we're focusing on.
Will that require super high bandwidth for the nodes?
Oh, I don't think so. We've done tests where we were doing the consensus, but we weren't actually handling the transactions locally, not actually processing them. And there we actually saw hundreds of thousands of transactions a second. So the gossip and the consensus are very, very fast. You can do gossip and consensus for hundreds of thousands a second. Then the real question is, well, how long does it take to process them? And we think that 100,000 payments per second being processed, where you check the signatures on them, and then you update the balances, we should be able to do 100,000 a second. But yeah, the time is basically spent in the processing of the transaction, not in the gossip and not in the consensus. Those are very fast.
So what sort of equipment would a node need to be able to join the network and contribute to consensus?
Yes, eventually we'll open it up for anonymous nodes where anybody can join. And then what we are saying is that you should have a good PC. We want you to have a good graphics card because we're going to use the graphics card to check your signatures on all of the transactions. It takes a lot of processing to check a digital signature. So we want a good GPU for that. That would be the most expensive part of your computer. But also, right now, we're having them have lots of RAM because we can be faster when we have lots of memory. And so that would be the other big expense right now. Over time, we may be able to have shards that have less RAM, but right now we're talking about lots of RAM and a graphics card.
If a node needs to be gossiping constantly to be able to contribute to consensus, is there a risk of centralization in that smaller nodes would be unable to meet that online participation criteria? And so we naturally just see larger and larger nodes?
Oh, I think it'll be very decentralized. So if you look right now at Bitcoin or Ethereum, the miners keep their computers on all the time. And they do have a number of miners. They're pretty decentralized. But we should be more decentralized because a node on our network will be even cheaper than a mining rig for Ethereum or Bitcoin. So we should be able to get more people doing it. And we do pay them. If they run a node, it will be a cheaper node than a Bitcoin mining rig or an Ethereum mining rig, and they get paid to run it. So I think that we will end up with having more people want to run nodes for us than we see right now on Ethereum and Bitcoin. But even better, if you're just an ordinary user and you don't want to run a node, you can take your coins and you can proxy stake them to someone else's node, and you actually get paid for that. And so you don't have to run a node to get paid, but you get paid more if you do run a node. And I think that we should have more nodes than Ethereum and Bitcoin because we're cheaper to run a node.
So even if I can't run a node or might choose not to, I can still effectively influence consensus and get a payment in return?
Right.
So in a sense, the participation threshold to be a miner in Hedera will be lower than in other coins like Bitcoin?
Yes. If you want to be a miner for us, it will cost you less than if you want to be a miner for Bitcoin. Now, we don't call our people miners because they're not actually mining. But yes, the equivalent of a miner, one of our nodes, is cheaper to run than a Bitcoin node. And so I expect we'll have even more of them. And then you, as a user, don't even have to run a node and you can still get some payments. You'd get more payments if you were a node, but even without a node, you can get payments too by proxy staking.
So let's move on to governance. The Hedera governance model is a council of 39 enterprises. Does that mean that Hedera is, in some sense, a consortium chain?
So it is a public ledger because anyone can use it anonymously. We will also be a non-permission ledger when we allow anyone to run nodes on it. So that will be non-permission. So it'll be public permissionless. The governance is more distributed than, say, Bitcoin or Ethereum. There, you just have a handful of developers that end up running it, and Vitalik and a few developers end up running it. With us, we're going to have 39 very large companies spread around the world that are running it. And so our governance will be more decentralized than you see with them. So the governance will be decentralized because it's 39 very independent companies around the world. Our nodes will be decentralized when we go to permissionless, and they're spread around the world. And then our users are public. We're public because the users can be anybody in the world using it. All three of those end up being decentralized.
So those 39 enterprises govern Hedera. They make the decisions. Do they also run nodes?
Oh, yes. The 39 make the decisions of what we're going to do. They decide what code will be updated, what features will be added, what the pricing of the fees are. The 39 are just the governors. They're the governing council. So initially, yes, they're going to run the nodes, but then we'll have other people running nodes. It will grow to lots and lots of people running nodes. The council, the 39, aren't the nodes. They're the governors. They're the ones that are in charge of it. That's all.
So will eventually other participants be able to run a node beyond those on the council?
Yes. So to start with, the nodes will just be run by the governors, but it will expand to lots of people that are not governors running the nodes. We want thousands or millions of nodes around the world.
So what happens if those 39 council members can't agree on a certain decision about governance?
It is a vote. We need more than 2/3 of them to agree to update the code or to transfer money out of the treasury or to make other big decisions like that. And they have to vote on it and they have to come to an agreement. If they could never agree, code would stop being updated.
Hedera also commits to never forking. How does that work?
Forking will not happen. And we have several different ways to stop forking. I think forking is very harmful because if somebody builds on top of the network and then it forks, we have a problem. So we have a technical mechanism that says if the network forks its state, that it has a way of proving which one is the real network and which one is the fake new network. And when the app on your phone talks to the network, it can get a mathematical proof, a cryptographic proof of which one it's talking to. That discourages forking of the state. And we have patents to legally discourage forking. So of course, somebody could violate the patent and fork the network, but then they wouldn't have a legal network, and big companies and serious users wouldn't want to build on top of a network that could shut down at any time because it's illegal. And so we have that. And so we even have things like automatic upgrade of the software so that it's very unlikely somebody isn't going to upgrade when we tell them to because we don't even talk to them. It just upgrades. So there's a number of different mechanisms here, but mainly the technical one of proving which network you're talking to and the legal one of having the patents. And then also just the names of the 39 in the council are big names. They make the network trusted and a fork would be less trusted. All of these mechanisms are being used to discourage forking. We really don't want forking. We're trying very hard not to have forking.
So there is the argument out there, the counter argument that forks are a feature and that they enable this sort of growth of new ideas and new experiments.
Well, the users don't want forks. I mean, if you want to build if you want to build CryptoKitties, you could build it on something that forks. But if you wanted to store, say, real estate, who owns which house on the ledger? And then somebody forks it. Now you have two ledgers that know where your house is owned, and maybe they diverge over time. And now one ledger says that I own your house, and the other ledger says you own your house. Nobody knows which one to believe. It would be a disaster. So if somebody is going to build a real estate recording app on top of it, they want one that's not going to fork. They really want to have a guarantee it's not going to fork. And so we're doing everything we can to make it reliable and stable for people who want to build on it.
Why would a large enterprise want to be on the council? Are they rewarded for that participation?
It's funny. They get rewarded for running a node. They don't actually get rewarded for being in governors. They do not get money for that. But what they do get is the ability to direct the future. This is the future infrastructure for the whole planet. And we have found that really big organizations are excited about that. So they don't get money. There's actually rules in the bylaws that say they can't steal the money from the company or from Hedera, but they can govern it and they can benefit from being associated with it.
So they don't directly receive payments for participating on the council?
Yes, exactly. At least they're not making money from Hedera. Now, they may get a PR value for being associated, and they can use the services at a discount. So they're saving some money when they use Hedera. But no, they can't, when you pay fees to use Hedera, your fees can never go to those companies. They're not allowed to take it. They don't get paid for being governors. They just govern.
How do we guard against some of the 39 conspiring together to do something nefarious?
So we have several different things to try to discourage them from doing something evil. One is that there's transparency. Anything evil they do will be very clear to the whole planet. The source code is being published for open review. Everyone can see the source code. People will be able to run these nodes and see if the code actually matches the source code. There's nothing they can do that is secret. Everybody will see what they're doing, and they're worried about their reputations. So if they do anything bad in that sense, everybody will know. And so they have a reason not to do something bad in that sense. They also live in many different countries under different governments. And so no one government could force them to do something. They're spread around the world on different continents. They're in different industries. So they have different interests. So they can't, all gang up and say, oh, we're all in the banking industry. Let's do something that benefits banks. Well, they're not. They're all spread out. They're all different things. We have one bank right now, and we'll ultimately have maybe 3 banks, but we're not going to have a lot. We have 18 different industries. So we're doing everything we can to make them be checks and balances on each other to prevent them from doing bad things. Also, they're just very large organizations. It'd be hard to bribe them to do something bad. For me to just go up and say, hey, here's $1 million, do something bad. That would be hard to do. So we're just taking into account that they're self-interested and that their interests are different enough that they act as checks on each other.
What's the role of the Hedera native token, the HBAR? Why do we need that?
Yeah, it does 2 roles. One is, of course, you have to use the token to use the network. You pay your fees using that token. And also, the token is how we pay the nodes to be nodes and how we pay ordinary users to be proxy staking. So you choose a node that you think is reliable and you get paid for having done the effort of finding a good node that you think is reliable. So the token is used for both the fees and the payments. Users pay the network with fees, and then the network pays both the users and the nodes with payments. The token is used for that. But of course, in addition to that, the token is the stake, and it is a proof of stake system. And so this is how we prevent, when there's anonymous nodes, this is how we prevent one person from creating 100 million nodes and dominating the network, because they only have influence proportional to how many coins they have. So a Sybil attack doesn't work. You can't stand up lots of computers and spread your coins among them and get any advantage. So that's why it's proof of stake, and the coins are used for that.
So what is the requirement for attacking Hedera? If I'm the bad guy, what do I need?
You cannot attack it unless you can get 1/3 of all the tokens in the world. That's the only way to attack it. We have math proofs, actually. It's ABFT, asynchronous busy fault tolerant, and it says if you get less than 1/3 of the tokens, you just can't attack it.
I feel like I should know this, but how big is the team? How many devs do we have?
Okay, I'm going to turn over to Mance now. We have 80 people, I think. But Mance, I've been talking all this time as we're into non-technical things. Would you like to talk?
Yeah, so in terms of formal members, we have 60 employees. Half of them are in engineering and product and the office of the CTO. And the other half are, standard business functions.
So the devs are in engineering?
Yes, so we do care about developers. And a lot of the work that we've been doing is putting together all of the documentation materials that would be needed for not just the startup community, but the enterprise community developers as well. So we care about both. We're focused not just on the dapps, the dapp community, which of course we are, but in addition to the dapp community, we are also targeting the enterprise developer community. And the council provides the perfect customer advisory board. The council members themselves, in part, are council members because they have dapps that they want to create, enterprise-grade distributed applications that they want to create. And, there's a difference between the two. When we talk about enterprise dapps, the tool sets that maybe they use when doing their development maybe is different than what sort of the startup dapps or the startup community might use. And so we've been focused on both. And yeah, a lot of work has gone into preparing for both communities to be able to use the network.
So Hedera is a platform, and a platform is nothing if apps don't build on it. How are we going to encourage that ecosystem?
We aren't focused on that today. Today, we're just focused on launching the network, or having what we call open availability. That means publicly available, which will happen sometime this summer. But then subsequent to that, after that, we'll be taking further steps to incentivize the dapps to be using the platform. Even now, though, we have several hundred dapps that have expressed interest in building product and are using our test network. And some of those dapps will launch with us whenever we have open access later this summer.
Would that include the possibility of some sort of fund to help dapps build on Hedera?
A fund? Yeah, no, we don't have it today, but it's likely that we will have it later. Once we've gotten through open access, then we'll turn our attention to something like a fund or something like an ecosystem. Maybe we call it a market development fund, something like that can be used to help the dapps in various ways economically to use the platform.
What do you think is the killer DApp for Hedera?
Yeah, Leemon, would you like to comment on that?
Sure. So to begin with, the speed we are emphasizing for the payments. And so we are making it so that they can be very fast, but that implies it can be very cheap. So you could pay somebody cryptocurrency and pay a small fraction of a cent in order to do so, which means you can open up new kinds of applications. Like you can be surfing the web and be paying a fraction of a cent to read each web page. Now, you couldn't do that if a cryptocurrency transaction cost you 50 cents or cost you $1. But if it's a small fraction of a cent, then you can talk about micropayments as you're surfing the web. And so this is an application that you can do, which I think is very interesting. We also have a lot of little features that allow us to act as a revocation service so that it works well with identity, to act as a timestamping service with fair timestamps, and it can be used for things like markets. And so there's some aspects of Hashgraph that are unusually good when you want to be matching up buyers and sellers and you want it to be fair. Or you want to have a patent office and you want it to be fair, who counts as being the first person to patent something? If you want to have an auction and you want it to be fair, who was the first person to bid? We have the fairness. So the speed that makes the price of payments very, very low, and then also the fairness allows you to do things like markets and things in a good way. Those are some of the aspects of it that we're optimizing. And then we do have smart contracts. We do have files, and they can be useful too. We have some interesting things with claims that we do that allow you to put identity type stuff on there. Those are very interesting. We can do all of that. But really what we have been emphasizing for speed has been the micropayments and some of those applications, and then the fairness.
Yeah, micropayments would seem to open up a whole new world of possibilities. Well, thanks very much, gentlemen.
Thank you.
Thank you for listening to Hedera Hashgraph's Gossip About Gossip. If you liked the episode, please subscribe, rate and review, and also share and tell your friends.
Or connect with us on social media like Twitter, Instagram, etc. at Hashgraph, particularly if you want to leave us feedback on the podcast. We look forward to hearing from you.